This worksheet is about arc length and sector area. So arc length is like the crust. How long is it from there to there? These are arcs. And sector area. So when you draw in a central angle like this, like the pizza or the pie itself, this is the sector. So sector area is how many. Do you guys remember what area means?
All the area in it.
A equals RT.
It's a way to measure how much space a two-dimensional object takes up by measuring it with square units, like square inches or square feet or square miles or square whatever. Anyway, how many squares fit in here? So sector area tells you how big this sector is based on how many square inches or whatever could fit inside here. So we got some formulas. You guys need to write these down somewhere because I'm going to be scrolling.
Okay.
I could put them up there, but I don't want to do that.
There's a turkey up there.
Get rid of the Christmas tree.
Oh, and
Man,
Merry
I'll
Christmas.
just leave it.
The box.
I'm hoping if I leave it up, they won't draw another one. Anyways, so sector area. Do you guys remember circle area? Maybe we should start with this. Circle area formula.
That was a lot of stuff.
Take that as a note. Pi r squared. Circumference? Question mark?
2 pi r squared.
No.
2 pi.
D.
2 pi r.
You got it.
Or just diameter times pi. This is where pi came from, by the way. They figured out that no matter what size the circle is, it takes a little bit more than 3 diameters to wrap around. So, like 1, 2, 3. You guys remember a diameter goes all the way across. Takes, no matter what size the circle is, takes a little more than 3 diameters to wrap around. Takes pi diameters to wrap around. So the circumference of a circle is diameter times pi. Okay, so let's start with sector area. Sector area is a fraction of the total surface, or the total circle area. What fraction is it? Well, it depends on what your angle is here. So for example, if your angle was 60 degrees, what fraction of the circle is that? 60 out of how many degrees in a total circle? It'd be like 1/6 of the circle. So the area of this sector would be 1/6 of the area of the entire circle. So the formula is
Circumference.
what? You say circumference? I'm making a little table here. You can't tell. Not a very big table.
Do that.
You do the area of the circle times the fraction of the circle that you're using.
Wait. It's,
Okay, what's theta represent?
the angle.
Angle.
The central angle, yeah, of the angle of the sector. And r represents the radius. So maybe it's like, 7 inches or whatever. All you do is plug that in. 7 squared times pi times, 60 or whatever over 360. And that is the sector area. Now, this is what we talked about yesterday, this one. Huh?
Are we going to have these formulas on
I don't know. I don't think I've made him do that in the past. Maybe I should, I don't know. I don't think I did. Probably not. Okay, radians. So the difference with radians is instead of like theta out of 360, it's theta out of 2 pi. Because remember in radians, 360 is equal to 2 pi. And what happens though is that this kind of cancels out. Do I write it with 1/2 or divide by 2? What do you guys want to use, 1/2 or divide by 2?
Divide by
Okay, so it's r squared theta divided by 2 is the... So just ignore this part. This is where it came from, but it simplifies to that. Okay, arc length. I was wrong. We did arc length with radians yesterday, so we talked about this one. It simplifies quite a bit. But arc length is from here to here. So arc length is a fraction of what? Arc length is a fraction of the circumference. Circumference is all this. How long around? If I walked this, how long around would it be? So arc length is just a fraction of that. What fraction is it? Well, like 60 out of 360. Same fraction as the sector area. So if it's a fraction of the circumference, we're basically using the circumference formula. 2 pi r times the actual fraction, theta over 360. This does reduce a little bit, but okay, I'll write the other version. The 2 and 360 can reduce to this, so this is a slightly simpler version. You guys know where pi is on a calculator, right?
Yeah.
Yup.
Okay, this one simplifies a lot when you use radians, because instead of 360, it would be 2 pi. And what happens to the 2 pi? They go bye-bye. So the formula is just radius times theta, if you're using radians for the angle. Let's just erase this so it's less cluttered. Let's just do that. Yeah, I'll leave that one alone. All right. I'm gonna scroll, so do you guys got these? Nobody's complaining? Okay. Number 1, find the length of each arc. So, yeah, on number 1, we're finding almost the entire circle's length, because the arc is 315 degrees. But the formula is arc length degrees, because it says 315 degrees. So, well, it's this one over here, I guess. The radius is 11 on number 1, and the angle, the central angle is 315. So I'm just going to plug those in. So pi times 11 times 315 over 180. And it says we're rounding to the 10th place, which is the first decimal place. What did we get?
60.47.
So that rounds to 60.5. I wonder if I have an answer sheet somewhere. I think I do. See if we got it right.
Whoa there,
Ding, ding, ding.
buckaroo.
Got it right. All right. So what's different on number 3 though?
Radians.
It's in radians. How can we tell? Because it says 3 pi over 2, not degrees. So we're going to use the radians formula, which is easy peasy. Yesterday I said I think this is why they made up radians, so it would be easier to do this. But radians is 3 pi over 2, or sorry, that's the radians. It goes for the angle. 3 pi over 2, and the radius is 16. Okay, Now, normally when we do this, like if we were in the book, they would just put 24 pi. But because these directions said round to the tens place, we want the decimal version. So just hit that decimal button on your calculator. You are correct.
How are you feeling, Mr. Jordan?
I'm lovely, thank you. Okay, 5 is the same thing, but they did not give us a picture. But 5 is degrees, 60 degrees, so we're going to be using the degrees formula, the top one. So it's pi times 18 times 60 divided by 180. You guys see where I'm getting this from? Looking right here. Pi times 18 times 60 degrees divided by 180. Let me see if I can get it. 19.2. Am I right? Nope. I'm wrong. It's 18.8. Number 7. Okay, 7 is same thing as 3. It's radians. 7 pi over 4 is the thing. So it's radius is 9. 7 pi over 4 is the theta, the angle. Ding. Number 9. Find the length of each arc. Okay. This one says do not round. So what do you think that means? It means leave pi in your answer. Don't change it to a decimal. Oh, but they did put 315 degrees on this one. Yeah, they weren't very clear about that. So what they wanted us to do, they didn't specify it very clearly. If we try plugging in 315, we will get a decimal. So what they wanted us to do, actually no, that's fine. We can still use the normal formula. I was going to say we can convert it to radians, but this will work. So the radius is 8, so that's going to go right there. The angle is 315. Oh yeah, sorry.
Let's go.
The radius is 8. The angle is 315. So we're going to go right there. I think the back is the sector area. Yeah. So radius is 8. Whoops. Angle is 315. Do you guys calculate spit this out automatically? Okay. Good. Okay, 11 is the easier version because it is radians. So it's just radius times radians. Can you guys do that without a calculator?
Or too high to do.
Willow looks afraid. 7 pi. a deer caught in the headlights.
No, I was like, I was thinking, I was like, it was probably 7.
Yeah, 14 is like 14 over 1, so they just reduce. Okay, anyways, send by. Okay. Next. I think the backs is pretty much the same thing, but with area, sector area. Okay, rounding to the tens place again. So, sector area formula, right there, with degrees. So we're gonna go pi times 10 squared times 60 over 360. You could reduce that in your head if you know that reduces to 1/6. This would be 100 pi over 6, 50 pi over 3. But we're doing decimals, so it comes out as 52.4. Inches squared. Why is it inches squared?
Area.
Because that's how you label area. Areas are two-dimensional measurements, like there's a length and a width. Circumference or arc length is a one-dimensional measurement. Just the outside of the circle. Okay. 15. Yeah, this sector area formula is not quite as simple as arc length. Yucky. So the radius is 4, so it's 4 squared times 3 pi over 2 over 2. Does anybody know an easier way to plug in 3 pi over 2? Three over 2 is 1.5. You could call that 1.5 pi. But you don't have to. I'm just saying it would be easier. I think this is 12 pi, which comes out to 37.7 centimeters. All right, 17 is kind of the same as the back side. The other side is we are not putting decimals. We're just leaving the fractions and pies and stuff. So it's 16 squared, radius squared times pi, 16 squared times pi, times the fraction of the circle we're using, which is 240 out of 360. This one doesn't come out nice. Well, we're leaving it as a fraction, so it's okay, but. Did your calculator handle it, or did it try to give you a decimal? It did it right. All right, 19. Radius squared, 14 squared, times pi, times 3 pi over 2, out of 2 pi. Oh gosh. Oh, what a mess. 3/4. 42, 21. All right. Let's see. Did I get it right? No. Oh, I forgot to square the 14. Oopsie. Oh, 49 times 147. Oh, I forgot to label these. Yeah, that's okay. No big deal. These are centimeters squared, the last one's feet squared. Okay. 21. The radius is 10 miles. This is a large circle. Okay, so we're going to do area of the circle, radius squared times pi, times the fraction of the circle, which is pi over 2 out of 2 pi. I didn't really use the simplified formula. I used the one that I understand, but you can use the simplified formula. I think it was 25 pi. All right. Yes. Miles squared. Pi r squared times 60 out of 360. This reduces to 1/6. This is 49. So it's 49/6 with the pi. Kilometers squared.